Hello children, in this lecture we will discuss group 13 elements, and group 13 elements are also known as boron family elements. So in group 13, boron, aluminium, gallium, indium and thallium are present, and their outermost shell electronic configuration is Ns2 and P1. So with group 13, P block elements or P block is started. So the outermost shell configuration is Ns2 and P1. Only boron is a non-metal in all of the 13 group elements, rest all are metals. Electronic configuration is given as outermost shell configuration 2s2 2p1 for boron, and for aluminium it is 3s2 3p1 and so on. Occurrence: boron is present in earth crust less than 0.001% by mass. In combined state, boron is present as orthoboric acid or borax and kernite. In India, borax occurs in Puga Valley and Sambar Lake. Aluminium is present 8.3% around in earth crust by weight, and the most important mineral of aluminium is bauxite. So most of the time aluminium is extracted from bauxite mineral or ore, bauxite ore. Okay, now rest of the elements, gallium, indium and thallium are less abundant metals than aluminium. So the highest concentration of gallium in the mineral germanite is about 0.1 to 1%. Indium and thallium occur in traces in sulfide ores of zinc and lead. Next heading: properties of 13 group elements. So first is electronic configuration. So as I have told you already that valence shell configuration is Ns2 and P1, where N is the number of outermost shell and it can be 2 to 6. Then atomic and physical properties. First heading: atomic and ionic radii. Atomic radius increases on moving down the group due to the presence of extra shell of electrons. So it is a general trend in periodic table, but there is an exception also. Atomic radius of gallium is slightly smaller than aluminium, but it should be larger than aluminium according to this trend. But here gallium size is smaller than aluminium atom. So it is because gallium contains electrons in the inner d orbitals also, and due to less shielding effect of d electrons, the effective nuclear charge on the outermost electron in gallium will be comparatively higher, and that is why these electrons will be attracted towards the nucleus more tightly comparatively, and so the radius will be shorter. Next, ionization enthalpy. So first, ionization enthalpy decreases from boron to aluminium, and it is expected so because increase in atomic size and screening effect. But after aluminium, there is no regular trend in the first ionization enthalpy value of gallium, indium and thallium. It is due to the filling of d orbitals in gallium and indium and f orbitals in thallium. So these orbitals d and f, which having electrons, are showing comparatively less screening or poor screening, and that is why the electrons, outermost electrons in gallium, indium and thallium are comparatively tightly arranged towards the nucleus. Okay, so overall on ionization enthalpy, two factors are showing their effect. The first is nuclear charge and the second is screening effect. Okay, so in gallium, indium and thallium, due to presence of d and f orbitals respectively, the nuclear charge will be more and screening effect will be comparatively less, and that is why the ionization enthalpy of the gallium, indium and thallium will be more in comparison to boron and aluminium. Okay, students. Then electronegativity. Boron, from boron to aluminium, it decreases and then increases down the group. Okay, and this is also due to the higher nuclear charge and less screening effect of the d or f electrons. Next property is electropositive character. Boron is a non-metal and rest of the elements of the group are metals and showing electropositive character. So electropositive character increases from boron to aluminium and then it decreases up to thallium. It can be explained on the basis of value of E naught. So as the E naught value is more negative, the related element or metal will be more electropositive. Okay, so students, if the reduction reaction for this reaction E naught value is less, means that element or metal will be more electropositive in nature. Okay, so less is the value of E naught, more will be the electropositive nature. Next heading is physical properties. Boron, non-metal, extremely hard and black colored solid. Rest of the members are soft metals with low melting point and high electrical conductivity. Gallium, with usually low melting point, could exist in liquid state during summer, and that is why it is useful material for measuring high temperatures. Density of the elements increases down the group as atomic mass increases from boron to thallium.